What is pipe? Pipe is a hollow tube with round section to facilitate the flow of the product. Product can be fluid, gas or pellet. Pipe is identified by nominal pipe size (NPS). If you see here 6-inch NPS along with the schedule number which is showing the thickness of the pipe. We are having 40 schedule, 80 schedule. Outer diameter will remain same. Inner diameter will keep on changing with the increase in thickness. For tube, it is always defined by its outside diameter, and thickness can be defined by BWG. Tubing is always having walls very thin, so this cannot be threaded. So this is a major difference between pipe and tube. This cannot be threaded. Tubes are used in exchanger piping, instrument air, instrument lines, small interconnecting piping on equipment such as compressor or boiler, etc. And we always go for ACME 36.10 and B36.19. These are the dimensional requirements. These standards are covering the dimensional requirements for the welded and seamless pipe and for stainless pipe. If you see here, it is very difficult to remember the ID and OD dimensions. So it is very easy to refer these two standards to get all the dimensional details. What is pipe schedule? Pipe schedule is just a dimensionless number which is representing the thickness of the pipe. It is very important thing because every pipe is designed to sustain some fluid pressure, and this is representing the strength indirectly. The outside diameter of pipe is same for all the schedule. Okay, if you see here, outside diameter for 6-inch pipe will remain same. With increase in schedule number from 40 to 80, the ID will keep on decreasing. Okay, for a given NPS, the OD remains fixed and wall thickness of pipe varies with increase in schedule number. As a result, ID of a given pipe decreases with the increase in schedule size. Okay, as the wall thickness is increasing, ID will keep on decreasing. With the increase in thickness of this pipe, the strength will keep on increasing. So lesser dia, more thickness, more strength. The OD of pipe and with NPS 14 or higher can easily be calculated by multiplying the NPS by 25.4. Okay, after 14 inch it will become a little bit uniform. There is no relationship between existing wall thickness, ODs and nominal pipes. Okay, to confuse everyone even more, we have other schedule also like 40, schedule 40, schedule 80. Along with this we have standard, extra strong, double strong. So many schedules are available. So to make it simple, we always refer these two dimensional ASME standards 36.10 and 36.19 for wrought and stainless pipe. So always refer these to get the dimensions, or if you can remember all the ODs and IDs, then it is also good. What is flange? Flange is a mechanical device to join pipes, valves, pumps and other equipment to form a piping system. Okay, it gives easy access for cleaning, inspection and modification. Flanges are usually welded or screwed, and we make a flange joint by adding flanges along with bolting system and a gasket in between. It helps in sealing the piping system also. The material of the flange is normally same as of the pipe. Pipe flanges are manufactured in all different materials like stainless steel, cast iron, aluminium, bronze, plastic, etc. But most commonly used is forged carbon steel and have machined surfaces. If you see, there are many types of flanges which we are using in piping system in chemical industry. Few are like welded neck flange, slip-on flange, socket weld flange, lap joint, threaded flange, blind flange. Okay, these are the commonly used flanges in piping industry. And if you see the dimensions details, we can always refer ASME section 16.5, ASME standard 16.5, and for material we can always refer to ASTM standards. What is slip-on flange? If you see, slip-on flange are attached by two fillet welds inside as well as outside the flange. This is very important to understand. If you see, two fillet welds outside, two fillet welds inside. So this is the basic arrangement how we are fitting the slip-on flange on a pipe. Strength of slip-on flange under internal pressure is of the order of 2/3 that of weld neck flanges. So these are not that much strong. if you compare it with weld neck flanges. And the life under fatigue, that means the to and fro flow of flow that is moving inside the pipe, is of the order of 1/3 of the weld neck flanges. If we compare these flanges with the weld neck, these are very weak, you can say, but they have their own application. That's why they are very popular in our piping industry. So this is a typical arrangement. This kind of flanges are normally seen like this. If you see, these are not most of the cases, these are forced construction, and only disadvantage of this flange is the combination of flange and elbow or flange and T is not possible. If you see, we cannot weld these T or elbow with the flange. It will always be welded with the pipe. So this kind of things are not possible for slip-on flanges. Socket welded flange. Socket welded flange are attached by one fillet weld only. If you see, only outside. In slip-on flanges we were having two fillet inside also, but here we are having outside only, and are not recommended for severe services. We will discuss why. These are used for small bore lines only. Okay, if you talk about the strength, it is nearly equal to the slip-on flanges, but under fatigue these are 50% stronger than slip-on flanges. Okay, by corrosive products and mainly in stainless steel piping system, the cracks between pipe and flanges can give corrosion problem. Why it is happening? Because we are having a clearance at bottom. If you see the X, this clearance will always be there for socket welded flanges, is usually to reduce the residual strength at the root of weld that occurs during solidification of the weld matter. Okay, when we are doing the welding, the residual stress needs to be accommodated. That's why we are keeping this much space, but at the same time this is acting as a disadvantage for the socket weld flange. Okay, because as we have discussed, the clearance is causing the corrosion problems. If you see, this is commonly seen socket welded flanges which are generally used in chemical industry. Screwed flanges. Screwed flanges or threaded flanges are used for pipelines where welding cannot be carried out. Okay, so this is the basic intention to use these flanges. Now cutting the threads on pipes, we require a thicker wall thickness. Okay, so this cannot be used on pipes where the thickness of pipe is less. So as per 31.3, it is recommended that wherever we are going to use screwed flanges, the wall thickness should be at least of the range of schedule 80. Okay, dimensional standard we need to refer 36.10, and schedule 80 or above we can go for threaded flanges. If you see, this is a threaded arrangement on pipe as well as flange. So this way these can be threaded to each other. This is a commonly used threaded screwed flanges in chemical industry, and these type of flanges are not recommended for services above 250 degree or below 45 degrees Celsius. Lap joint flanges. Lap joint flanges are very unique and useful thing which we are using in piping system where piping is of costly material. For example, in stainless steel piping, a carbon steel flange can be used. Okay, because why we can use it in this system? Because the flange will never come in contact with the product of the pipe. If you see here, this is pipe and this is the lap flanges. The fluid which will be flowing inside, it will never come in contact with the flange. This is the commonly seen lap joint flange in piping industry. If you see, these are nearly identical to the slip-on flange, but the pressure holding ability is very little. Okay, these are nearly equal to the slip-on flanges, and but at the same time fatigue life of the assembly of this joint is nearly 1/10 of the weld neck flanges because of its low fatigue strength. As we have compared it with the weld neck flanges, these joints are used for low pressure and non-critical services. Weld neck flange. Weld neck flanges are known as long tapered hub that goes gradually over to the wall thickness of pipe. If you see here, this is long tapered hub which goes gradually to the pipe so that it matches with the pipe thickness. These are bored to match the inside diameter of mating pipe or fitting. If you see here, this is matching with the connecting pipe. There may be a fitting instead of pipe. Okay, this long tapered hub, which is playing a very important role, it provides an important reinforcement. Okay, this portion provides a reinforcement for use in several applications. They also provide excellent stress distribution. Okay, so this is very important part of weld neck flange, which is providing reinforcement as well as stress distribution through the tapered hub. If you see, this is the weld neck flange, which is normally used in chemical industry for piping systems. Services involved high pressure, zero, sub-zero and elevated temperature. Because of its this reinforcement nature, and this is very strong type of flange, so this can be used at high pressure and elevated temperatures, and also used for critical services where all the weld joints need radiographic inspection. Okay, so this is its uses where based on this we can use in piping systems in our chemical industry. Blind flanges. Blind flanges are without a bore and used to blank off or blind the ends of the piping system or valves or pressure vessel openings. Okay, so you will find this kind of thing to blind the items. Now if you see, this is a blind flange. Here it is blind flange, point number 1. It is used along with any other flange, along with the gasket in between and a bolting arrangement. This is actual picture you will find at site. If you ever go to site, you can see this kind of arrangement. This is used to blind the system. These type of flanges are very stressed. Why? Because there is no standard inside diameter. Internal pressure and bolting loading is also there. Okay, these bolting loads will be there, and internal pressure on this blind flange will be very high, which makes it highly stressed flange. Okay, because of this, stresses are pointed near the center, and since there is no standard inside diameter, these flanges are suitable for higher pressure temperature applications. Okay, so what is a valve? Any device that stops, starts or changes the direction or magnitude of any fluid flow or its pressure, that is called valve. So what is its main function? It may stop or start, or it can change the direction or its magnitude. Okay, because of the diversity of types of systems, we have so many piping system in our oil and gas field, fluids and environment in which valves must operate. Okay, so you can have n number of permutation combination where different type of valves will be there. So we are having vast array of valves types that have been developed. Valve is a very important component in our piping section, because it's cost up to 20 to 30% of the piping cost of a plant. The cost of a given type can vary depending on the type, size and material of construction. Okay, but in most of the cases it consists of around 20 to 30% of the total piping cost. So selection of valve is extremely important to the economics as well as operation of the process plant. So that's why this valve is very important component which we need to understand, so that we can implement our understanding into our piping designings. So what does a valve do? Okay, if we try to understand what is, we have already discussed what is valve, what it does, we need to understand. Valve has some of the following functions, like we have already discussed it in its definition: starting, stopping and directing. This is the basic function. It can regulate, control or throttling the flow. Okay, we'll discuss in detail each and every word, because this is important to understand the function of the valve. Preventing backflow, this also is a very important thing which we will discuss in detail in coming sections. Relieving or regulating pressure, this is again a very important function of any valve. So we'll discuss all these functions in detail one by one in our coming videos and in this video also. So there are two basic principles based on which a valve works. Okay, by putting a stopper in a line. Okay, if we put a stopper in a line, it will obstruct the flow. It can affect the rotating impact and a sliding function. So obstructing, moving the stopper by direct thrust. If you see in this case, if we push, if we stop the flow, it is flowing like this, and we obstruct the flow, then it will stop. Okay, on the orifice sitting. So rotating, the stopper can be rotated in field, for example in ball valve, plug and butterfly valves. the rotating impact will be there to stop the flow. Then sliding will be there in mostly gate valves. Stopper is slid across the face of the orifice sitting. Okay, so these are three of the principles based on which all these valves are functioning: obstructing, rotating, and sliding. Okay, so if you uh, list out all the types of valve, we can classify all the valves based on application into four categories: isolation valves, regulation valves, non-return valves, and special purpose valves. Okay, in isolation, what we are doing, we are isolating the flow. These are the valves which are commonly used in oil and gas, and these are the types: gate valve, ball valves, then plug valve, butterfly valves, and DBB valves. In regulation, globe valves, needle valves, butterfly valves. Butterfly is here and here also. Diaphragm valves, pinch valves, ball valves. Okay, again these are there. Then plug valve, again it is under isolation as well as regulation. Non-return valves, swing type, lift check valve, dual plate, axial flow check valves. Non-slam, sampling valves, multiple valves. These all valves comes under special purpose valves. Okay, so this is the classification based on which all the valves can be categorized. Okay, now we'll discuss in further videos on each and every section. For example, in next video we'll discuss all the isolation valves, okay, in detail. Then in next part I'm dividing into four another parts where we'll discuss each and every part in detail. Okay, all the valves will be discussed in further sections. So if you see, what is a gate valve? What does it do? A linear motion valve in which a closure element slides into the flow stream to provide shut off. Okay, if you see in this picture, here is a sliding element which slides down and it obstructs the flow. This is the basic thing which we need to know about gate valve. What are the interesting facts about it? Suitably only on and off applications, not for throttling. Okay, throttling we will discuss in detail when we discuss the regulating valves in next part. For example, the globe valve. Here it is not suitable for throttling. Now why it is not suitable? Because the sliding part is there. If we shut it partially, then the flow velocity will be very high because the full opening will not be there, so it may damage the sealing where this wedge is going to rest. Okay, so to avoid that, we are not going to use this kind of valves for throttling. Typically has a low pressure drop. Okay, this is one of the basic property where we are going to use gate valves. Inexpensive, relatively easy to maintain. Okay, its manufacturing way is very easy, it's simple to manufacture, so and it can be used at many places. Slow response, high operating time. We have to rotate it and the slider will go down and it will obstruct, so a little bit time taking, but it's very commonly used. Difficult to open against extremely high pressure drops. Okay, this is another drawback. Gate valves may have cast or forced body, bolted or welded bonnet, full or reduced bore, rising or non-rising stems. Okay, so this is just a property of its manufacturing thing, like its bonnet and how it is rotating, how it is moving down, how the bonnet is holding the things, and how wedge is moving. So in gate valve, this is the basic thing, but discussion on gate valve is incomplete if we don't discuss what kind of wedges are there. Okay, so let us start in detail discussion on this, then only the discussion on gate valve will be completed. So if you see, we are having three type of wedges. Okay, solid wedge, then flexible wedge, then split wedge, which we call parallel disc gate valves. Okay, so this, based on this three wedge design, we have three categories of gate valves. So now why these are different, why these are required, what is the purpose, what are the drawbacks, what are the plus points? Let us discuss one by one. Popular because of its simplicity and strength. This is very common design. This rotates and this comes down and it obstructs the flow. So this is very easy to design. This is very simple and very easy to design, and it's very strong also at the same time. Easy to manufacture, suitable for almost all fluids. Okay, although this is a topic of discussion for process team, but just to know whether it is suitable for all the fluids or not. Susceptible to leakages as it does not compensate for changes in the seat alignment due to pipe loads or thermal expansion. Okay, suppose there is a high temperature fluid is going on and there is some expansion or contraction take place, then this wedge may block inside the seats. So it may be, it may be at some point of time, maybe it is very difficult to open or close the valve. So in that case, it is not performing well. It may result into thermal locking. So thermal locking may happen in which wedge is stuck between the seats due to expansion of the metal. So this is one of the drawbacks also. It is very simple to manufacture, very strong and commonly used, suitable for all the fluids, but at thermal expansions it gets locked. It may get locked. So this is only drawback we are having with this kind of wedge, which is solid wedge gate valves. Then another part is flexible wedge gate valve. What is different here from solid wedge to flexible wedge? Cut on the wedge parameter gives more flexibility but compromises the strength. Here what we are having a cut in between. Okay, although we are adding this cut to have some flexibility, but it compromises the strength at the same time. It improves the sitting alignment. Why we are making a cut? As we have discussed here, there may be a misalignment with the sitting seats. Why we are giving here a cut? To have the flexibility to align the wedge with the sitting arrangement. So in this case, improved sitting arrangement is there. So often better leak tightness. Okay, when it is aligned with the sitting and it is doing better tightness, so leakage chances are very less. Performs in thermal binding situation. As we have discussed here, thermal locking may happen here. It performs better in case of thermal binding situations. Line fluid tends to collect in the disc. Okay, some fluid may collect here, which may cause some corrosion and may weaken the disc. So this is one of the drawback here in this kind of flexible wedge gate valves. Third part is split wedge parallel discs gate valves. Okay, what is different here if we compare it with these two wedges? Consist of two solid pieces. If you see, we are having two different pieces. These are two separate pieces here. Can be a wedge shape or parallel disc. This can be a parallel or can be a wedge shape. Parallel discs are spring loaded. If you see here, there is small spring in between the two pieces. This spring helps in better sealing. Okay, the wedge is sitting properly between the seats, so better sealing is there, so less chances of leakage. In case one half of this disc is out of alignment, the disc is free to adjust itself to the sitting surface. So again it is better and it is helping in the sitting arrangement, which were the major drawback here, seat alignment. So this is best in this thing. Freedom of movement of the disc prevents the thermal binding. So thermal binding, which was a problem here, which is mitigated in this case. So that's why this one is better as compared to this thing. Although this is very easy to manufacture, this is having some complication. So some drawbacks and some benefits are there based on that, based on process requirement, based on other properties, we can select one of these wedges. So this was all about gate valves, which we have covered in this section. Second part is ball valves. So how these are performing? Rotational motion valve that uses a ball shaped element to stop, start or regulate the fluid flow. If you see, we are using the word regulate here. It is stopping and starting, but at the same time regulation is also there. So this ball valve will be part of second section also, where we are going to discuss the regulation valve instead of isolation valves. So if you see, what are the interesting facts related to ball valves? Suited for conditions where quick on and off, tight shut off are required. If you see, we have to turn this handle by 90°. So that means it is a very quick on and off action is there, and it is very good in tightening. Minimum pressure loss when fully opened. Okay, there is low pressure drop as we have discussed in case of gate valve. Here also pressure loss is very less. Zero leakage, as we have discussed, is very tight shut off, so that means zero leakage is there. Available in soft seat and metal seat designs. Okay, the seating can be soft seated or metal seated. Both type of designs are there based on process requirement and metallurgy requirement. We can select both. Soft seated are used only for low temperature services up to 200°. Metal seated are used for high temperature services. Okay, so this is the governing factor how we can select for soft seated and metal seated. Metal seated are used for high temperature services. This is the common thing wherever we are going to have high temperature, we go for metal seated valves. Extremely bulky in larger diameters. The size is very high if we go for higher sizes because the ball size increases with the diameter. Expensive in large diameter and when metal to metal seats are required. So as we go for higher sizes and go for metal seated, that means for higher temperature, it becomes a little bit expensive. Okay, now we are having two types of ball valves. One is floating type, another is trunnion mounted valve. So this is what is main difference between floating and trunnion is how the valve, this ball is resting. Okay, in this case, as the name suggests, it is floating. That means it is floating in between these seats. Okay, when the flow is there, it this seating arrangement stops it, so it seals here and vice versa. So it is always floating, suitable for small sizes, suitable for low and medium pressure. Ball is supported by two resilient seats. Okay, two resilient seats. At the same time, if we discuss the ball valve trunnion mounted type, the ball is trunnion supported. If you see here, this is the basic difference. If you compare here, this is floating, this is not resting. Okay, the ball is having different type of contact with the seal. Here what is happening, it is ball is resting at one location and it is not changing its contact surface area with the seating arrangement, and it is supported by the trunnion type arrangement. So we are calling it trunnion seal, and it is suitable for high pressure and large sizes. So this is a basic difference. Here we are going for low and medium pressure. Here we are going for high pressure and large sizes. These valves floating type are used for small sizes. And if you see, these are the plug valves. Rotational motion valve used full flow service where quick shut off is required. Okay, as we have discussed in the ball valve, if the plug 90° is rotated from open position, the solid part of the plug blocks the port and stop flow. This is similar to ball valve operation. Okay, as we have discussed in the ball valve section, operation is nearly similar. Here instead of valve ball, we are having plug. Okay, so mostly the purpose and operation is similar. Used for air vapor service, natural gas piping system, and vacuum to high pressure applications. So this is somewhere we are going to use these kind of valves. Again, as we have discussed in ball valve, this is also quick to open or close and can be serviced in place. It is very easy and we can service it at place. These kind of things we can unbolt and we can do the service if required at its own place. We don't have to remove it and to bring it at somewhere else. We can do it at in place. Provide reliable leak tight service. Okay, again this is very tight and very less leakage is expected. Required greater force to actuate due to high friction. Okay, plug is moving, so there is a kind of high friction available with sleeved construction, metal to metal. Okay, this kind of construction is available in plug type valves. The lubrication of the seating surface is by means of lubricant which is fed into the operating surfaces. Okay, this is kind of we can do the lubrication. Okay, so this is just a representation. Flow is coming in when it is this side, handle is 90° to the flow, then it is closed. When it is throttling is happening, when it is partially opened, when the handle is in the flow direction, then it is open. Again we try to avoid this situation, because it, again we have as we have discussed in case of gate valve, partial open, if we keep it in partial opening for a longer period, then it the flow will increase and it can damage the sitting of the valve. So we avoid it. Throttling, we don't use this kind of valve for throttling. Next one is butterfly valve. This is also isolation valve, the rotatory motion valve, which is used to stop, regulate and start fluid flow. Okay, start, stop and regulation. So this is not only isolation valve, this is regulation valve also. Well suited for handling of large flow of liquids or gases at relatively low pressure. Okay, we'll in next slide we'll discuss what kind of butterfly valves we are having and why few of these we can use for low pressure, and how we can use these kind of valves for high pressure also. Zero leakage available, economical in higher sizes. We'll discuss this in detail in next slide, why higher sizes are economical. Require considerable less space compared to gate valve, globe and other valves, and light in weight. If you will see next slide the pictorial view of these valves, then you will understand why this is taking less space, why these are light in weight, and how these are cheaper as compared to other valves. Maintenance cost is very low. Full bore opening not available because of the disc in the flow path, and hence cannot be used in the line to be picked. Available in valve, wafer, lugged and flanged version. This thing we will discuss in detail in next slide. Okay, so here what we have discussed, the disc is moving 90°, so it will obstruct the path, so full opening is never possible. If you see how we are going to classify the butterfly valves, there are two categories based on which we can categorize all these butterfly valves. First one is as per body construction. Okay, then as per disc configuration. Based on body construction, we are having 5 types with us: wafer type, semi lug, lug type through and through bolts, lug type with body tap holes, threaded ones. Okay, then the fledged end type. These are the 5 types for which we have categorized based on as per construction, body construction. Okay, then another category is based on disc configuration, zero offset, which we call concentric type. Then under centric we are having 3 types: single valve, double offset, then triple offset. Okay, if you see wafer type looks like this, a very simple configuration, very thin, no flanges, only disc which is moving 90° in the valve body. Then semi lug type, we are having lugs here. Okay, lugs here, then again the disc is moving 90° inside the valve body. Then we are having lug type, here we are having lugs all around. Okay, through which we can put our studs also. So we'll having this through and through holes where studs will be moving and it will be connecting to the connecting flanges. Similarly here we are having double flanged valve. This is the only valve, butterfly valve, where we are having flanged on both sides. In these cases we don't have any flange, so that's why we have very compact design, very light design and very economical design. So this one is a little bit costly as we are adding 2 flanges also. So this is the basic category based on body of construction. We are categorizing into these 5 types. This is very important section where we are categorizing based on disc configuration. If you see here, zero offset configuration, single offset configuration. Why it is zero configuration? Because the center line of disc and shaft is at same point, so there is no offset. Okay, so we call it concentric type butterfly valve. Here what we are doing, here the, if you see this point is at center, if you see here this point is not at center, that means we are offsetting it by some distance. Okay, so this is the offset distance from the shaft. That's why we are calling it single offset eccentric valve. Again, we have third category where we are doing the double offset. How we are doing the double offset? Here it was along this line. Here we are offsetting from this point also. Again, we are not touching the body at center. This offset is there, this offset is there. So double offset we are having with the disc. Here we are having a third category with triple offset. How we are having triple offset? First this one, second this one, third one is with the sitting arrangement. This is at angle. Okay, this angle is at the causing the third offset. Okay, so based on this configuration we are categorizing into 4 parts. Okay, now let us look at each of these section, all these valves one by one in detail in next slide. We'll have a pictorial view for each valve and how and why these offsets are required. Okay, we'll discuss in detail in next slide. So if you see, we have these type of valves which we have discussed: wafer type, semi lug, lug type, double valve. Okay, so now look at the pictorial view, how these valve looks like. Single or zero offset, this is concentric, it is matching with the center. Okay, these valves are not having any flange, so very simple, very light, very uh, cheap, you can say. Then we are having lug type. Okay, semi lug type, we are having lugs here. Okay, and these are again flangeless valves. If you see this category here, the bolts are moving through the connecting flanges between the lugs. Okay, if you remove all these studs, if you unbolt all these studs, then valve will be removed and these lugs will remain here. Okay, so it will be easy to handle. Okay, so that's why these lugs are provided and we call it semi lug type valve. Then we are having lug type. This was semi lug type, this is lug type. How it is different from semi lug type? We are having lugs all around. If you see, sorry, this is through bolt points and we are having lugs here. We can handle it from these points. Okay, and we can bolt it through these holes. If you see the actual picture, these are the lugs and studs are moving through these lugs and we can bolt it on both sides. So this is just a pictorial view of lug type. Same is double flange type. We are having two flanges on both sides of the valve and the bolting arrangement will be like this. This blue flange is flange which is a part of valve and these brown ones are the connecting one, and we are having bolts this side, bolts this side, again this side and this side. So this one is a very heavy design and it is again having two flanges, so it is a costly design also. So all these are the valves which belong to this category, which we have categorized based on the body configuration. Now this is very interesting part here, based on which we have categorized butterfly valve into 3-4 categories: zero offset, double offset, single offset, triple offset. Okay, now let us discuss how and why we have done these offsets and what are the benefits. Okay, let us start with the zero offset category. Here what is happening, if you see, this is a open position, the disc is like this is partially opened, this is fully closed. Now disc center line, shaft center line valves are matching. Okay, so that's why this is zero offset, there is no offset at all. Okay, in single offset what we are doing, we are doing an offset here. This is the center line of the disc, sorry, the shaft, and we have done some offset. This is a disc which is at some offset, so this is one offset only, so we call it single offset. Now in what is happening in double offset, if you see, this is the center line. Okay, from this center line we are having one offset here and one offset here, so this is double offset. In triple offset what is happening, these two offsets are already there. Again we are having third offset, which is with the sealing arrangement, sitting arrangement. Okay, we are having this. In next slide we'll discuss how we can do this, how we can understand in detail. In next slide we'll cover this. Here what we are going to discuss, what are the benefits of having these three categories. Single offset is suited for fire protection, water treatment and cooling water systems. Okay, there we go for this kind of arrangement. Double offset, where we are going to use low pressure to medium pressure. Okay, class 150 to 300. And what are the categories? Hydrocarbon, steam and other process applications, where we are going for this kind of valves. Triple offset valves are used for medium to high pressure. Okay, up to class 900. Then hydrocarbon, steam and other process application for temperature up to 1200 Fahrenheit. So these are the benefits of this category. We are having four categories here. Now let us go one step further. Let us try to understand why these offsets are there. Okay, and why we are going for these offset. Otherwise this valve is also okay, this is also butterfly, these are also butterfly. Why we are going for this offset? How we are going to manage these offsets 1, 2 and 3. Now this is very interesting part. If you try to understand how this double, single and triple offset disc is moving inside the butterfly body, butterfly valve body, then it will be very interesting. So let us see if how we are having three configuration. If we start with this point, okay, we are having a butterfly valve and its disc inside it. Then we cannot rotate it, it will not move because this point will obstruct with the sitting. If we try to offset this center point from this point, from this point to this point, then there will be less touching area between disc and sitting. Okay, this is the double offset type valve if you see. But after trying everything, there will be some portion, a small portion which will touch with the ceiling, with the seat. Okay, to avoid this, here we are going to have metal sitting, metal seated valve. Metal seat will be there, disc is also metal, then there will be a metal to metal contact. Okay, so small touch with the seat, it can damage the seat, which will be very costly to repair. So what we are doing, we are having at the touching point a elastic plate. When this disc will touch it, it will move a little, but it will avoid damaging it. Okay, so touching we cannot avoid, very small portion will be touching here as compared to this one, it will be very less. But how we are mitigating it? By putting a elastic plate at this point. Okay, what is happening in triple offset? We have shifted this point from this point to third offset. Okay, now we can, once this will be, this disc is rotating keeping this point center, then there will be no touch at all with the seat. Okay, so this is a very safe design, there is no metal to metal contact, no chance of damage. Okay, so this is a typical configuration of triple offset valve. Okay, if you see here, this is a straight configuration which is similar to this, and if we shift this point center line shaft to this point along with the angle, okay, so this is becoming the third offset. So in third offset there is no contact between disc and seat. Here there is small contact between disc and seat, but we are mitigating by putting this point. So what is happening in double offset valve? When the disc rotates, small rubbing takes place between disc and seat. As we have discussed, there is small touch is there. As there is a metal to metal contact, to mitigate the erosion issue on the surface, the elastic plate is added at the point of contact. So if you see, this one is added at the point of contact. Double offset valves can handle high pressure and high temperature. Very simple design as compared to triple offset. Okay, hence comparatively very cheap. what is happening in triple offset? When the disc rotates, there is no contact between disc and seat, hence triple offset valves have long life. Okay, we have discussed there is no contact, so there is very robust design, but it will help to have long life. At the same time, when these valves have very complicated design, hence huge cost difference between double and triple offset valves. Metal to metal contact between disc, hence robust design and can handle high temperature and high pressure. So this is the basic design things and interesting facts about butterfly valve, different type of butterfly valves, double, triple and single offset valves. I hope you enjoyed this section. In next part we are DBB. DBB block and bleed valve consists of two isolation valves with one bleed valve. Okay, so this is nothing but having all this arrangement in a smaller size. Okay, so we are going to have space benefit, weight, cost saving versus multi-valve system. Reduced installation and maintenance requirement. This is very small, very easy to install, and maintenance is very simple. Mainly used in instrument isolation and available in ball, needle configuration. Okay, so this is very simple concept which we generally use for isolation, actually double isolation. So first one is globe valve. Okay, if you see a linear motion valve used to stop, start and regulate. Okay, here the additional is regulation. These are the regulation valves, so we can regulate the flow. This is the main principle. Okay, we want to regulate the flow, that's why we are going to use this type of valve. The globe valve is used for throttling control, flow control. Okay, now what is throttling? This is a nice concept which is globally used, for which the globe valves are used. Shutoff is accomplished by moving the disc against the flow stream rather than across it, as in the case of gate valve. Okay, if you see, okay, we'll come back to this thing. First, let us have a look at different type of globe valves. First one is Z or T type, Y type, angle type. Okay, now what is happening in this case? The flow is coming like this. When it is coming, we have to close. When we are closing the valve, we have to go against the flow. Flow is coming up and this closer is coming down, so it is going against the flow. Here also it is going against the flow. Here again it is going against the flow when we are closing it. So when the shutoff is complete by moving the disc against the flow, there will be throttling. Okay, the process in which high pressure fluid is converted into low pressure by using throttle valve is called throttling. Throttling will happen only when we are moving something against the flow. There will be huge pressure drop. So these are the main features. General purpose control valve, efficient throttling. Throttling is the main purpose for this valve. These valves can handle throttling application, frequent stroking and wide temperature extremes. Much higher pressure drop than gate valve. Available in straight, Y and angle pattern, as you discussed, straight, Y and angle pattern. In higher size, it can weight considerably more than a rotary valve and is much more costly. Okay, so these are few of the features, and if you see what are the benefits and disadvantages of this type of valve. Obstruction in flow lead to high head loss, which we have already discussed here. There is a huge pressure drop when the flow is against the movement of closer. High pressure and pulsation can damage internal trim parts. Okay, when there is a huge pressure, then the internal trim parts may get damaged. Most of the valves are heavier than other valves if we consider valves within the same pressure class. Okay, the globe valves are generally very heavy. Better shut off but costlier than gate valve. The main purpose of shutting down is better as compared to gate valve, but it is a little bit more costlier. These valves are very easy to do maintenance because we can open it from top and we can remove the faulty part. Another one is needle valve. This is also regulation valve. Needle valves are sometimes referred to as plunger valves also. Okay, because we are having a plunger type arrangement inside it. These are also regulating valves and enables to control and regulate water flow and pressure very precisely. Okay, so this is the main function here. These valve can regulate very precisely. Needle valves are similar to shut-off valves. They are used to start, stop and regulate. Okay, that's why it is under this regulation category, the flow rate within the pipeline. Unlike shut-off valves, needle valves have a long tapered needle-like point at the end of valve stem. If you see here, we are having needle type point at the end of valve stem. This is often referred as plunger. Okay, we call it plunger. Because of its unique design, a needle valve can precisely, accurately control the flow. Okay, this is a special feature of this valve. This can precisely control the flow. Hence, needle valve generally used for instrument gauges and meter line services. Okay, in instrumentation we need to go for very precise readings and displays. So in those cases we can go for this kind of valve. Accurate throttling is possible and therefore extensively used in applications that involve high pressure and high temperature. One is accurate throttling, then precise control. So these two features make this valve very useful, especially in instrumentation. Another one is diaphragm valve. Okay, diaphragm valve, if you see here, we are having a diaphragm here. It is in a closed position. Then when the same diaphragm is in open position, it looks like this. Okay, flow is moving like this and it can pass through it. Diaphragm valve uses a flexible sheet pressed close to the edge of the solid dam to narrow the flow. This is pressed against the flow and it becomes closed. Used for shut-off and throttling valve. Again we are going against the flow. That means it is producing the throttling effect. There will be huge pressure drop. Operating part of diaphragm isolated from service. This is a very unique feature here. If you see, diaphragm is isolating the flow from the other body parts. So there is no chance of entering the fluid inside the body. That is making it very useful. This makes the valve suitable for viscous and corrosive services. Okay, because it is not allowing the fluid to enter anywhere else. There are no packing glands to maintain and no possibility of stem leakage in the valve. When fluid is not entering, so there is no chance of leaking from anywhere else. Precise throttling may be difficult to achieve due to elasticity of the diaphragm. As we have discussed in needle type valve, their precise throttling is very much possible. That feature is not available here because we are dealing with the elastic diaphragm. Okay, this is a small drawback here, but still these valves are very much useful for throttling purpose and shut off purpose. So check valve is nothing but it's designed to automatically prevent the reversal of flow. When we want to allow the flow in a single particular direction, then only these valves are useful. So these are self-actuated and require no external means to actuate the valves. There is no handle, no stem, no body for stem holding. So these are very simple to construct and means to actuate the valve either to open or close. So these are very fast acting valves. Difficult to determine whether the valve is open or closed because we don't have any rotating handle from external, so that we know whether we have to close it or open it. These are all self-actuated valves. If you see, we have different types of check valves. First one is piston type. This is a category of lift type check valves. One is piston type, another one is ball type. If you see, this one is ball type. What is happening inside this valve? If you see, piston or ball, this is a piston or ball which is held open during normal flow. If the flow is toward this direction, this will push the disc or ball towards upward and it will flow like this. So this is in open position. If you see, flow will move from this to this. Okay, As the flow slows or stops, the ball or piston closes the opening, preventing the flow from reversing. If the flow gets slow, or the amount of flow is less, then this piston or this valve will come down and close the opening. So there is no reverse flow. There is no reverse flow like this. Okay, so this is the main function. The flow is itself raises it up, and when it comes down, then reverse flow is not possible. This one is swing type check valves. If you see, flapper is held open during normal flow condition, closes shut if the flow reverses or stops. Easy to maintain, self closing. In larger size, the flapper becomes very heavy, which can cause slamming and water hammering problems. If you see how these valves look like, there is a disc which swings around this point. Okay, it swings when flow comes, this opens and it reverses, it closes down when it comes back. So there is no reverse flow. Okay, so this is very easy to construct, very easy to use. There is no handle rotating part. This is self closing, self actuating valve. And for higher sizes, when the flow comes, this disc starts hitting the seal, so these may get damaged. So for higher sizes, we go for multi swing check valves. If you see, there are 1 2 3 swing. Okay, so as the size increases, pressure increases, we can use swing type, but with multi-port type of check valve. So this one is check valve dual plate type. Okay, dual plate check valve is lighter, smaller, more efficient, less expensive, and has better non-slam characteristics than conventional swing check valve. Okay, so if you see, there are two spring mounted on flapper plates, assists the plate in closing when the flow stops and begins to reverse. Okay, if you see, there is a spring. This spring looks like this. These are two plates, 1 and 2, both are spring operated. When the flow is coming, at first it is closed. When the flow is coming, then this plate, this spring against the spring, these plates opens up. Okay, and the flow passes through the valve. When it tries to reverse, then the spring brings it back to its closed position, so there will be no reverse flow. Okay, if you see, this is the red color one is spring, and these two are plates. Now this one is a special case of check valve, which we call non-slam type. To understand the functioning of non-slam, we have to understand or compare it with the swing type check valve. Okay, now we have already discussed this type of swing type check valve, where it is opening with the flow and getting closed. If you see, if a swing valve sees a number of slamming incidents, slamming incident means one, it's open, it closes, it opens and it closes, then it start hitting at the seat, so it may get damaged, and there will be a repeated action which will cause some damage to the seats. If a swing sees a number of slamming incidents, it is possible for the hinged pin which is holding the disc in place to crack or break off. Okay, this hinge may get damaged. Okay, when the swing check finally closes, it abruptly stops the flow. When it is in a closed position, it abruptly stops the flow, okay, which is coming back, and causes a pressure surge resulting in the shock waves. If you see, this kind of shock waves will be generated once it gets closed. So these shock waves again creates pressure which may damage the valve. What is happening in non-slam, it utilizes a coil spring. If you see, there is a coil spring inside this valve downstream from the valve disc that moves the disc towards the seat. Okay, this spring brings it back to the seat as soon as the flow velocity slows down. Okay, as the flow velocity slows down, it slowly comes back. The spring helps it bring back to the position, closed position, This valve is designed to be closed just before zero flow is reached. Okay, when zero flow is, then it slowly closes the and brings it to the closed position, thereby eliminated backflow. With no backflow, the cause of water hammer disappears. Okay, if you see, the pressure spikes, waves are very less if you compare it with swing type, and here non-slam check valve. This is the difference. The shock wave is very less and it goes and it disappears very fast. Okay, so this way this non-slam check valve is different from swing type check valve. Y type strainers. These are the devices which are used to separate unwanted solid particles from gas, liquid or steam which are flowing in the pipe. Their name is derived from its shape. If you see, it is Y type shape, so that's why we call it Y type strainers. Okay, these are available both as butt welded joint and flanged connections. Filtering element should be on the downstream, that is flow is towards this side, so that the debris are collected in this portion. Advantage of Y type strainer is these can be installed in horizontal or vertical position, so that means we get very good flexibility in our piping layout. Using Y strainer, it is a very cost effective method of straining fluid transmitting through the pipelines. And the uses, if you see, most appropriate and commonly used item as a permanent installation. Okay, where small and solid particles are expected, so that less frequent cleanout is required. Its shape and compactness make it ideal for handling high pressure conditions also. We are using perforated wire type mesh which act as a filtration element which is located in this portion. And when you want to do the maintenance, you can when the line is shut down, you can open this part and the filter can be removed and it can be cleaned. Then again it will be inserted inside and this can be again bolted. If you see at bottom of the portion, there is a drain connection which with sometime we get a valve connection also here, so you can open the valve and drain out unwanted items. Basket type strainers, if you see, it is a closed vessel with cleanable screen element installed inside which can retain foreign particles from various flowing fluids. Okay, these are designed for installation in horizontal line only, so that's why we are getting less flexibility. We cannot use it in vertical lines, and these are mostly used for liquid service only. Basket type strainers are also found as a duplex style also, where we are getting two cylinders. Okay, with the diverting valves. This diverting valve will divert the flow from one basket to another. If one is under maintenance, then we can use the second one, so that we cannot interrupt the flow. As we know, filtration area is very high in basket type strainers, so high flow capacity can be used, and low pressure drop horizontal applications. So its main application is with high flow capacity and low pressure drop horizontal applications. Basket strainers remove the dirt from the system that can damage the moving element. Hence, these strainers are also maximizing the life of pumps and other equipment. Ideal for steam, air, water, oil and gas lines. For maintenance, it is very easy. We can easily remove the cover, and we can get the access into the inside parts, so that we can do the maintenance or cleanup activities easily. T-type strainers. These are custom fabricated item designed to remove the foreign particles from the pipeline. Okay, if you see, this can be mounted in vertical or horizontal piping, so we are getting a complete flexibility here in piping system. T-type strainers are also used as permanent strainers, mostly for 2-inch and above line sizes, available with welded or flanged ends. These are available in both the scenarios. Flow direction, here if you see, the flow direction is horizontal and here it is at 90-degree. So we are getting a very good flexibility based on layout requirement. We can go for any of these configurations. Also in T-type strainer, we are having one drain point on the blinded portion at the lower side, so that we can drain out while operating the line also. Without taking into the maintenance, we can do it or before maintenance also we can open the drain and remove the debris from the pipe. Again we are having two tappings on pipe both side of the strainer, so that we can measure the pressure differential. Okay, this pressure differential indicates how much amount of foreign matter trapped inside the screen. Okay, so this is very good indication. Based on that we can plan our clean out activities. And in this case, if we are not getting vendor data in the starting of the project, we can always go ahead with T dimensions, which are standard one, along with the weld neck flanges. So we can go ahead with our design, piping system design based on these dimensions. Conical strainers, although these are very simple to design, but they carry out very big jobs in our piping systems. Based on their shape, we are calling it conical. Conical strainers offer a large filtration area, letting you catch more debris. Okay, these are normally installed in a temporary operation. However, they are used as permanent installation also in many cases. Mostly these are used during the startup of the plant. Once the startup is done, then we can always remove it from the piping system. It uses perforated wire or mesh or wedge wire to trap the suspended solids. Conical strainers are usually installed horizontal, not vertical, in piping system, and the most commonly used in piping to prevent damage of gauges, pumps, control valves, flow meters, and other process equipment. So these are very simple to design and very easy to use, very easy to maintain. Steam trap. Steam trap is an automatic drain valve which separates the steam and condensate. Now it holds back the steam and discharges the condensate, which is the main objective of using steam trap. Okay, quick removal of air and other non-condensable gases is also essential for running the steam system. Now, why we are using the steam trap? If you see in any of the plant, we are generating steam by a boiler or any other thing. What is the purpose of that steam? We want to heat the product. Okay, by using this steam we will heat the product somewhere in the plant, so that's why it is very important. And when steam loses its energy by heating the product, condensate is formed. Okay, this is one way of forming the condensate. Whenever steam is used to heat the product, some condensate will be formed. Along with that, some condensate will be formed because of radiation losses. When steam is passing through the pipes, some radiation loss will be there, then again condensate will be formed. So that's why we are having condensate in the steam system. Now main agenda here is to remove the condensate immediately as it forms, because it will reduce the operating of efficiency of the system if we don't remove it immediately. Okay, presence of condensate in the steam system can also cause physical damage. How it is causing physical damage? If you see, there is a water hammering phenomena. The condensate accumulate in the bottom of the pipe, okay, with steam passes over it. Incompressible water traveling at very high speed, when it suddenly stopped by pipe bend or any other obstruction in the pipe, then it will cause the water hammering. So it can cause mechanical damage also. So there are different type of steam traps. If you see, based on the principle, working principle and mechanism, we have divided into three parts: density operated, temperature operated, kinetic operated. Okay, we'll discuss each and every one in separate parts. Density operated mechanical traps. Steam and water have different densities, and this is basic principle of these traps, along with the optional air vent in between. If you see, we are having two type of traps: ball float and inverted bucket. This is ball float. Here also we are having a air vent. In bucket type also we are having here air vent. Okay, now the principle of ball float is steam or condensate, whichever is entering here, it will start accumulating. This ball is hollow inside. As the condensate level increases up to certain level, this ball will come up and the port will open. Condensate can remove from here. Air will come out from this part. If the steam portion is increased here in this portion, this bellow will expand and this port will be closed. So there will be very less loss of steam. So this is the basic principle of ball float. What is the principle of inverted bucket? If you see, we are having a bucket here. Again, a port valve is there. This is air trap. Now the steam is coming inside from this portion. When the steam is more, due to 0.4, this bucket, inverted bucket, will go up. When it is up, this portion will be closing the port. Along with time, if the condensate start increasing, or due to radiation loss, this steam converts into condensate. The portion of condensate at this portion will increase, and this will lower the bucket. So once it is lowered, this port will open and the condensate can go out. So this is the basic principle which we are using here, the difference of density between water and steam. Thermostatic traps, as the name suggested, these are temperature operated and works on the principle of temperature difference between steam and condensate. As you know, condensate is always at lower temperature as compared to steam, and that is the basic principle. Based on temperature of the inlet fluid, if steam is entering or condensate is entering, based on that this trap is working. Now to understand the working principle, we need to understand this bellow inside this trap is charged with the liquid which evaporates at or below boiling point of water. Okay, this is the basic principle of working here. If steam is entering, this charge inside the bellow will evaporate and it will increase the pressure and it will expand and close the valve. Again, with when condensate is coming, and with the course of time, this steam inside the bellow will start getting condensed, then temperature inside the bellow will start decreasing and more condensate will be formed, less steam, less pressure, so this will be contracted and the valve will be opened. Okay, so based on the temperature of inlet fluid, if steam is there, this will expand, if condensate is there, this will contract and it will closed and open based on temperature of inlet fluid. Thermodynamic steam traps. These are the traps which works on the principle of thermodynamic Bernoulli's principle. Okay, that is, with increase in velocity, pressure decreases. So if you see, these type of steam traps are also called disc type of traps. The disc is there. This is a disc chamber where the volume is substantially high as compared to the inlet and outlet port. Okay, and it operates based on the change in state of condensate to steam. Okay, so change of state controls the opening and closing of the disc. This is the basic principle. How it operates: when the condensate comes, it lifts the disc upwards and it opens up. Okay, when it is open position, then at some point of time, when the temperature of the condensate is significantly high, it start changing its state into steam. Okay, a small portion it gets converted into steam. When it gets converted into steam, the velocity of passing the condensate out increases. When velocity is increased at this section, then pressure starts dropping. When pressure starts dropping, then the disc starts coming down. Okay, then the steam starts coming, accumulating at upper portion of the disc, which further pushes the disc and closes the trap. So this is the basic principle where the disc opens or closes based on change in state of condensate. Okay, along with that, there is provision, because sometime air or some non-condensable things will be there which we need to remove along with the condensate. Then we need to grind the surface below the disc in such a way that air or non-condensable gases removes automatically. Plastic pipes. If you see, thermoplastic, thermosetting, these are the two types of plastic pipe which we are using in our piping industry. Thermo means heat. Okay, we are heating, these getting softened by heating and hardened by cooling. These are thermoplastic. Thermosetting, these are cannot be remelted. Once it is hardened by heating, this cannot be remelted. Okay, thermoplastic is very frequently used for commercial and industrial applications such as conveying chilled process, water, aqua solutions for corrosive chemicals, slurries, food, okay, waste substances that must remain uncontaminated. So this is very useful for meeting this property. Okay, the types are HDDP, HDPE, PVC, PVDP, CPVC. This is most commonly used chlorinated polyvinyl chloride. Okay, at the same time, if you see the thermosetting resin, okay, these are always combined with reinforcement, sometimes filler such as sand, to produce structurally integrated composite. Okay, this is very strong thing. If you compare with steel, it is having a very good application here. So basic applications include potable water, sea water, water treatment, fire water. Okay, so it is having good application in piping industry. If you see the commonly used RTRP, reinforced thermosetting resin. Okay, these three words, if you can understand, then we can understand the whole concept. Reinforced, how we are reinforcing glass fiber or carbon fiber. Thermosetting we have already discussed. It is hardened by heated and cannot be remelted. Then resin, we are using this kind of resin, polyester, vinyl ester, epoxy. Okay. FRP, we call it FRP also, fiber reinforced plastic. Fiber reinforced plastic. Okay, GRE, GRP and GRP, epoxy plastic and vinyl ester. So these are few of the pictures which you can see, and just to visualize how things are happening there. What is jacketed pipe? Jacket is, if you see the word, it is a jacket around the pipe which is further protected by an insulating cover, typically used for transportation of hot steam or water. Okay. Now this is the main purpose is to maintain the temperature of the material flowing inside the core pipe. Okay. To further understand this concept, there is the inner pipe which we call core. Okay. Then outer pipe which we call a jacket. Okay, this is further protected. If you see, we are using this word, further protected by insulation. Okay, further protected by insulation. So the three layers will be there: inner, outer and insulation cover. It is preferable to have basic material of core and jacket same. Now the material of jacket and core pipe will remain same, so that there are no stresses are developed. Due to differential expansion of the two material, stresses may develop, so we try to use the same materials to avoid this situation. Commonly used heating material mediums are steam and hot oil, okay, which is flowing through the jacket. Now what are the methods of jacketing? We are having two methods: fully jacketed and partially jacketed. In fully jacketed, what is there? We are doing the jacketing from flange to flange, okay, end to end we are doing the jacketing, that is called full jacket. In partial, we are not extending it to flange, we are terminating in between, somewhere before the flange. So if you see where we are using the fully jacketed pipe lines, where we have to maintain the narrow temperature range, this is the only criteria we are using. Okay, typically used for sulfur lines. Partially jacketed, where we are not going to maintain very narrow range of temperature. Okay, less critical to maintain the process within a narrow range. Applications mainly are drain collecting lines in trenches. Okay, so this is a basic concept related to jacketed pipe. Steam trace lines: a tube or a small dia pipe attached to the pipe carrying a heating medium for the addition of heat all along the process line is commonly referred to as heat tracing. Okay, if you see here, there is a core pipe which is having fluid inside, and this is a steam tracer pipe which is further protected by the insulation cover. Okay, why we are doing this? Because if the process temperature is to remain same, the heat input through this line should be equal to the heat loss by the core pipe. We have to maintain the temperature inside, so the heat loss from this pipe, heat input by this pipe should be equal, so that we can maintain the properties of the fluid inside the pipe. Okay, now why steam tracing is very important? Because this is, in any of the plant, steam is integral part. Okay, so we can easily get the steam distribution in any of the plant, very commonly found thing. And the important thing is distribution headers may often be found in proximity of the pipe. Wherever we want to do the steam tracing, you will most of the cases you will find the steam tracing distribution steam header distribution header near the required one. So we can always distribute from that header. Now there is one manifold, steam manifold, then condensate manifold. This is a very common thing which we are getting supply, and then condensation we are collecting to the condensation manifolds. Okay, so this is very useful concept to maintain the temperature inside this. At the same time, installation of steam tracing is very flexible because we are getting steam very easily. Distribution headers are always nearby, so we can always take tappings and do this kind of arrangement. Cost of installation is very less as compared to jacketing. Okay, maintenance of jacketing pipe is very difficult as compared to steam manifolds and everything. So it is very useful concept to maintain the temperature inside the pipe. Electric heat tracing. If you see, electric heat tracing consists of installation of cables along the pipe to provide heating. Okay, all these cabling will be there all around the pipes, all around the pipe. If you see all the valves and all the instrument, again this arrangement will be there. When piping is, why we are going for this electric heat tracing? When piping is exposed to very low temperature, there is a risk that the fluid inside may be frozen. Okay, to avoid this situation, we have to balance the heat loss from the pipe with the heat input by the cabling. Okay, so this, once we are balancing this thing, then the purpose is fulfilled. Now electric heat tracing is also known as surface heating or heat tape. It is important to note that the heat tracing is not limited to pipe but vessels also. Okay, we go for heat tracing of vessels also. Now heat tracing by electric or steam is purely client choice. If steam is available at very reasonable cost, then client go for steam tracing. Otherwise we can go for electric tracing also. Now the application, as we have already discussed, the temperature maintenance, freeze protection, foundation of heating. Sometime for tanks and other things we can go for foundation heating also. There also this is very useful. Long pipeline heating, snow and pipe freezing. Now if you see, there will be one junction box, cabling will be there all around the pipe, then there will be a termination point, and we can supply the electricity from this thing. So this is the total arrangement for electric heat tracing. Lined and ABE coated pipes. Okay, these are internally or externally coated pipes. Now first let us try to understand why we require this coating. Okay, what we are doing, we are combining two material. One is carbon steel and internal piping, internal lining. Okay, what we are doing, we are combining these things. What we are getting in combining this, mechanical properties of carbon steel and low cost of carbon steel, when it is combined with the lining material, we will be getting something which is very useful in chemical industry. Okay, why it is important? Our main agenda is to avoid corrosion. Okay, we need to prevent leaks, consequent possible environmental disaster, fire, explosion, and service disruption. These everything what we keep on putting our effort to get something which is at low cost and mechanically very strong. So when we combine carbon steel with the lining material, we get something like this, which is very useful in our industry. Okay, so at low cost we will be getting something which can be used for various services, process requirements it will meet. Okay, what we are having, parent pipe which is carbon steel, then lining. Based on metallurgy and carbon process, we get these three recommendation: PTFE, PP and PE. This is the material which is used as a lining material in carbon steel. Okay, in fitting also we can do the similar arrangement. These are internal piping, internal coating. Okay, at the same time we are having FBE coating with us, which is externally coated. Okay, how we are doing it? We are doing by fusion bonding. What is this fusion bonding? When we are applying this film wets and flows onto the steel surface on which it is applied, soon becomes a solid coating. Okay, by a chemical cross linking. What is this cross linking? This is fusion bonding. Based on this we call it fusion bonded epoxy coating. Okay, so this is external coated, this is internal coated. Purpose is to get something mechanically strong which can be used in chemical industry. Advantages and disadvantages of non-metallic pipes. If you see, we are having rubber piping, concrete piping, ceramic piping, plastic piping. Okay, these are used in chemical industry along with the carbon steel. Okay, so these are having their own benefits, advantages and disadvantages. Let us discuss a few of those. For example, the main advantages of non-metallic piping is lower cost. Okay, as if we compare it with the metallic one, carbon steel or any other pipe material, then it is very low in cost. Okay, lower manufacturing cost and installation cost. So it is very cheaper as compared to steel. No cathodic protection is required. Okay, corrosion monitoring is not required, which is very much required in metallic, for example in steel. Resistance to many corrosive fluids. Okay, this is main advantage. No chemical inhibitors are required. If we are using non-metallic, then these are not required. Flow properties are superior to steel pipe. Okay, lesser friction and all other benefits are there. Lower pumping cost. Okay, so cost is a major benefit. Pumping cost is less, manufacturing cost is less, installation cost is less. Okay, consistent friction factor, therefore more life of the pipe. So these are the main advantages. At the same time, if you see what are the main disadvantages of using non-metallic piping are, they cannot bear more temperature. So temperature limits are there as compared to steel. Pressure limits are there. We cannot go for very high pressure as we go for in steel piping. Hydrocarbon cannot always flow through the non-metallic pipes. Okay, we need to look into the process recommendation. Non-metallic pipes will degrade in sunlight. Okay, sunlight is a major drawback because these will be exposed to sunlight. Heating effect will be there. Ultraviolet inhibitors will be required. Very susceptible to the mechanical damage. Okay, these are very soft as compared to carbon steel pipes. So these are very easy to break. More flexible than carbon steel. Require more supporting than steel piping. Okay, so these are few of the disadvantages. So these are having very important factor. They play very important factor in our chemical industry. So these are few of the advantages and disadvantages.
So let us start with the definition of piping study. If you see, piping study is nothing but half science and half art. Art means if a person who is doing the piping layout is creative and his visualization is very good, then he can come up with very beautiful layouts. Along with this art, some certain established knobs we have to follow. Then only we can come up with a proper layout. So let us have a look what is the scope of this piping engineering, where it is used. It is used in chemical process industries, pharmaceutical, power plant, and along with this long distance LNG, LPG, CNG piping systems. And major areas of work, how we complete our piping engineering, we have to do piping layout, piping stress, and piping material. We'll discuss all these three areas in detail in coming slides, but in this video we are going to cover the introduction part only. Let us see what is piping layout. If you see in any refinery, in any plant, gas plant, everywhere we have few equipment, buildings, structures, platforms, ladders, stairs. So piping layout is nothing but the arrangement of these things, but as per engineering codes and standards. Most of the time the piping routing is done according to the PNID. PNID is a process document which is base foundation for layout people. We'll discuss in detail this piping PNIDs, process and PNID diagram. Along with this, we have to fulfill few stress requirements, supporting, and not only this thing, but the accessibility to all instrumentation valves, erection of equipment, maintenance, and other statutory regulations. So what we are expecting from piping layout people, the piping layout should be feasible from construction point of view. Whatever we do, we should take into consideration the construction constraints. They should not face any kind of problem while erection, maintenance, and operation. So this is the main priority. Piping layout shall be economical. In this any of the refinery, we have to procure so many things like pipe fittings, equipment, structural requirements. So at every point, we have to take care of economical issues. So we have to be very economical. And piping layout should be safe. Safety is the first requirement, and it should be aesthetical. It should look good also. So to prepare this piping layout, many documents are required. For example, the process and instrumentation diagram, that is PNAD, plot plan, equipment layout, and equipment foundation drawing. These things we receive at very preliminary stage at the start of developing of piping layout, and in the main run we develop all these things. There is a main output from piping layout people: mechanical data sheets, equipment vendor drawings, electrical and instrumentation cable layout, building layout, and line list. Once a piping person receive all these documents, then only he can start developing their piping layouts. This is introduction to stress. Piping stress. Now there are so many complicated piping: critical piping, non-critical piping. We call it the piping system. At every point of time, piping system will be carrying some fluid which will be at different temperature, pressure. It will be having its own weight. There will be weight of pipe also. So at different time there will be expansion or contraction, thermal expansion or contraction. So everything we need to take care. To take care of all these things, we perform stress analysis. That in stress analysis we ensure that piping is rooted and supported so that no damage occurs to either the pipe or the associated equipment. To perform the stress analysis, stress team require process, instrument diagram, equipment layout, and line list. Then comes to piping material. PMS, piping material specification, is the basic document which is used throughout the life cycle of the project to select the material which we are going to use in construction and fabrication of all process and utility piping. To develop PMS, following documents are required: process fluid list, which will be given by process team, then process line list for maximum line size, inputs from licensor. These are the feed documents which you receive at the starting of the project. Piping design basis, project and E specification, post-weld heat treatment requirements, class rating is decided for valves and flanges, thickness calculation is done for deciding the schedule of the pipe. We'll discuss all these things in detail in coming slides or in coming videos. This is just an introduction. What are the various documents which are required to prepare the PMS? If you see, this is the typical EPC organogram where we can see all the disciplines which are involved. Let's start from bottom. If you see, we are having process, piping, civil, mechanical, electrical, instrumentation, and few other departments are there which are directly doing the engineering part. Okay, along with this engineering, we are having its procurement and construction. If you see the center part of this slide, procurement, engineering, and construction, we call it EPC. Along with this, we are having our quality assurance department and HSE, health safety engineering department. So all these departments are managed by project management team. Along with this engineering group, we are having our service departments, which involves admin, IT, document control, HR, and accounts. So if you see, this is a very typical engineering where we have all these departments connected to each other. So this is a typical EPC organogram. Let us look at how piping organogram looks like. So this is a typical piping organogram, piping discipline. If you see, we are having our head of department, lead engineering, pool of engineering engineers, then pool of designers and modelers. Along with this, we'll have a look at how these team members are interacting with each other. If you see, HOD is directly interacting with lead engineer, and lead engineer is replying back to HOD. And HOD is responsible to interact with project team, and project is dealing not only with the technical teams but with client also. Now, project team is interacting with HOD as well as client. Along with these two major stakeholders, they are interacting with lead engineer also. Okay, so HOD and lead engineers are always interacting with other disciplines, like it is mentioned in bottom right corner: civil, instrumentation, mechanical, electrical process, and other teams. Okay, so other than engineering, we are having procurement and vendors. like piping team is interacting with procurement team. They are directly interacting with vendors and they are getting and sharing the information from vendor to the piping team. Okay, so this is a typical organogram where piping engineering is involved. So this here we can see how things are interacting and how project is done.